The precommissioning test. Precommissioning test is necessary or it is a statutory requirement. It ensures that all the installation is done as per the safety regulation. It ensures that good materials are used and good workmanship have done the work. The installation is in good working condition. If there is any fault in the area, remedial measures are taken before energizing the installation. Every wiring installation on completion and before energizing has to be inspected and tested as per IS 73289 section 5 and has to satisfy the requirement. First, visual inspection is done to verify the installation. It is applicable as per the Indian standard specification and correct. It will check the factors that it will check whether it is done as per the Indian electricity rule or NEC and whether it is correctly erected or not with the relevant code. And it also checks whether there is any visual damage, that is which can be seen from outside. Testing of installation is usually done by various methods. Continuity test of the final circuit conductor. Continuity test is carried out in all final circuit to make sure that there is no discontinuity of supply. Also, continuity of protective conductors including main and supplementary equipment is also done to make sure that electricity can easily flow through the circuit or it is electrically sound and are correctly connected. This will include all protective conductors and other conductive parts used for providing equipotential bonding. The resistance of the earth electrode is also measured and it has to be as per IS 3043 Code of Practice for Earthing. Insulation resistance of large installation are to be carried out by dividing the installation into similar units of each containing not less than 50 outlet. The test voltage is to be applied for insulation measurement. For voltage up to 250 volt, the applied voltage is 500 volt. For 250 to 500 volt, applied voltage is 1000 volt. For above 500 volt, applied voltage is 2500 volt. Insulation measurements are recorded between the installation and the earth and between the line conductors. The steps that are followed in the measurement of insulation resistance between conductor and earth is: the main switch is positioned in the off position. All fuses MCB's main switch are placed. All fuses MCB beyond the main switch is in on condition. All lamps and other accessories are in place. The phase conductor and the neutral conductor are connected together near the main switch on the consumer side. The insulation resistance between the conductor phase and neutral conductor connected together and the earth is measured using mega ohm meter of appropriate voltage class. The measured value should not be less than 1 mega ohm. For measuring insulation between conductors, the following steps are followed. The main switch is placed in the off position. The phase and the neutral conductors are not connected together. All switches are in the on position. All lamps are removed. All fuses beyond the main switch of the consumers are kept on. The insulation resistance between the two phases are recorded using mega ohm, and the insulation recorded should be greater than 1 mega ohm or it should not be less than 1 mega ohm. When equipments are disconnected from the installation for the above test, and if the equipments are exposed, conductive parts to be connected to the protective conductor, the insulation resistance between the exposed conductive parts and live conductors shall be measured separately. The steps followed in conducting the polarity test is: all equipments are disconnected, all switches are kept open, use a test lamp of long lead, touch one end of the lead to the neutral point, touch the other end to the input terminal of the switch. If lamp burns, the polarity is correct. A battery source can also be used for this purpose. When protective measures are incorporated in the installation, which operates on the principle of leakage current, the earth fault loop impedance plays an important role. Earth fault loop impedance is measured with the help of a measuring loop standard method of measuring the loop impedance. In installation, when residual current devices are mandatory for providing protection against indirect contact, the effectiveness of residual load devices can be tested by simulating the artificial fault condition on the installation. This testing is independent of any test facility provided on the device by the manufacturer.